So, my name's Marcus Hanwell. I attended Camp KDE last year, and this is where I found my new job. I started working for Kitware about 3 months ago now, but I've been contributing to KDE for a number of years. Working in KDE Edu, I took a very windy path as well. Got a PhD in physics in the end and decided I actually preferred tackling the software problems in physics than doing the physics. And so I ended up at Kitware, and they do a lot of big scientific problems using Qt and C++. A little bit about Kitware. They were founded back in '98, quite a small company in the beginning. They've grown very quickly. It's privately held. Revenues, I think, around 9 million. There are about 30 PhDs in the company, so it's fairly PhD and developer heavy. But it's a cool place to work. I've enjoyed it so far. The center of everything Kitware does is really about software process, and many people who work on KDE only really know about the CMake part, but the testing is an integral part of supercomputing visualization that takes up most of my time, as well as the medical imaging, the computer vision, and data publication. They're all things that are continually tested. VTK has more than 1.5 million lines of code, and when people make changes, we need to ensure that these continue to work. And so VTK has more than 1,100 regression tests. It's run across 55 platforms, I believe, every day. And this is all done automatically, and developers are emailed when they commit code that creates problems. Some of the other projects that Kitware works on, CMake, which I'll go through. VTK and ITK are more about the visualization and medical imaging. And then ParaView, which I work on quite a lot, which is a Qt application that leverages VTK. Image-guided surgery toolkit, which is a really cool project I've not done any work on, but it helps surgeons to perform better. And then some other things such as BatchMake. And I wanted to talk a little bit about this. It's just a very quick slide, but Narmic is something that Kitware is involved in, and this is an open science project. It's both open source and open data, very much along the lines of Philip Bourne's talk, where it's NIH National Center, and Kitware is leading the engineering core of most of this work. So this is VTK-generated images, and there's actually a large amount of funding now to port Slicer from KW widgets over to Qt and to modernize the user interface. And this is really aimed at the leading edge of the clinical researchers out there, and it's widely used in that community. And this is BSD licensed and widely available, funded by the NIH. So CMake, the new book is due out pretty soon. It's currently at the printers. It's a good source of documentation, but you can also look on the wiki, and I monitor the mailing lists. And I'm also working on some of the new testing improvements. I'm starting to work with Alexander Nerndorf. This is a little bit about how software generally works at Kitware, and it's just a short comic strip about agile programming, and how in some companies it is just, we're not going to make any plans anymore, we're just going to write code and hope it works. But you need some kind of process to be able to innovate in the software and not worry too much when you make these changes. And Kitware's solution to this is C-test and C-dash. So we have a workflow for Kitware developers, and this is a workflow that could easily be adapted for KDE, where the developer checks in new code, and it goes into the software repository, whether that's Git or SVN. Then we have build servers that actually build the project, and then they send the results of that back to C-dash. That acts as a source where it collates all these results, so you can see build errors, build warnings, and you can also look at regression tests. So even without adding any tests, you can see warnings from Windows, you can see warnings from Linux, Mac, and whatever other weird platforms, BSD, we might be able to get on there. And every developer can see that without having to run that operating system themselves, which even without any of the regression testing can improve the software quality by immediately notifying each day that you've introduced a regression that broke the Windows build, for example. So the key components of CMake are obviously CMake, which does all the building, but C-test is tightly integrated with CMake, and it can understand the cache, and it can get most of the information from there, and so it was a natural progression to start using C-test to be able to submit results from builds. And C-dash is really the aggregation, so it's a MySQL, it's a LAMP stack, it's a MySQL application, PHP, and it just aggregates these results and presents them to developers, and it can also email developers if they subscribe when they commit changes that cause new errors or warnings or test failures. And then you've got CPAC, which I'm not going to really talk about today, but this is cross-platform packaging, which can be used, and I've used it in Avogadro, which I've talked about at previous Camp KDE. So yeah, CMake was strongly affected by KDE, as you can see. And in 2006, it really changed the web trends. And right now, there are more than 1,200 downloads a day, and that's not even counting most of the distros, which obviously package it themselves and they're not registered. It's used in KDE and Second Life. Boost has begun to use it, and many other projects are migrating over. And CMake really aims to give a build system that can be used across all platforms. And so we try to abstract away most of the details of building on different platforms. And in my own personal experience in Avogadro and Calcium, we've been able to make this work very well across Windows, Mac, and Linux. These are a few of the larger users of the toolkit. So originally, CMake was developed for ITK, which was this big collaboration between a lot of scientific bodies. And then it became a project on its own right and began to be developed. VTK was migrated over, Paraview, and then KDE got involved, as I said, and there's Trilinus, Scribus. MySQL is using it experimentally on Windows, I believe. LLVM, I recently found out NVIDIA use it as an internal build tool. And so it's getting more and more widely used, and we have a whole host of supporters that are willing to put up financial backing to help us develop it and extend it and make it work better. And this was just a really cool use I found out about recently, where it's actually used to build software that powers some automated systems, where they have these little buggies that drive around the fields, and it's just a random use of CMake. For those of you who use CMake, you probably know all this, but I thought I'd give it a little background. It's cross-platform, so it works very well on Windows, Mac OS X, Linux. We use it on supercomputing clusters. High-performance computing embedded is getting better and better, but there's obviously more work to do there. It generates native build systems, which is very different to many other build systems. So if you want to use Visual Studio, it will make a solution file. And you can use Visual Studio as you would use on most other Visual Studio projects. And in OpenBabel, a project I worked on, we actually had separate Visual Studio solutions that had to be maintained. And whenever you added a file, if you didn't add it there, the Windows developers would complain. And it allows you to get rid of that, and you can still choose to use Xcode or Visual Studio. Most developers don't need to worry about which particular IDE you might be using. We have generators that take care of it, and generators are reasonably easy to add as well. The out-of-source build trees, which I think most of us appreciate around here. Interactive configuration. So the Qt-based GUI for CMake is actually quite useful for turning options on and off and seeing what's available. It has tooltips which usually provide documentation for what those options are for. And then you've got multiple configurations. So most of my projects I'll build debug in a release version so I can develop them more efficiently. There are a few more little bits, such as automatic analysis. Fortran is one of the more unusual things where it can do dependency analysis for builds. One of the nice features that it doesn't seem very big at first, but the coloring and the percentage completion when you're building a very big project, it's nice to be able to glance at the console and see roughly how far through it is. Assembly targets. Make help will display all the different targets if you just want to build a small part of your project. Make fast is actually quite nice when you want to build small parts and skip the dependency analysis. And the language is reasonably simple. Thankfully now we can use lowercase for function names, which I like a lot better. And the loops can be a lot looser. The new style of finding packages such as Qt is quite nice and compact as well, so you can select the components you would like to use just in one line of code, along with the version that you need. And just include the use file, and this will build a minimal Qt project. If you want to do a little more, you can add mock headers, etc. And very little really changes when you want to use KDE as a target to build against. You can again specify the version, add a few source files, and most of the hard work is taken care of by the modules that the KDE community maintain. You've also got some CMake scripts which allow you to do cross-platform copying. So instead of using the shell, CMake abstracts away copying, removing files, etc. And that's using the -e as a command. And you can also use script mode, where you can use CMake as a scripting platform, and it will work cross-platform again. So a rough sequence of events: you read a CMake cache. If there isn't one, then a new one is created. Read the CMake lists files, and then you'll write the updated CMake cache, and this can be repeated. And then when we go to generating, we write the make files, project solutions, or whatever else. And these are what are used to actually do the building. And so that will be Unix make files on Linux, and then Xcode projects or solution files. This is what I really wanted to address today, is the benefits of testing and automating as much of this as we can, because we're always short on resources. And if we can automate more of this, then it helps with our project, and it will improve the quality of the code. So since I moved to Kitware, I've really begun to appreciate the value of having continuous dashboards that constantly rebuild whenever something changes in the project. And I'll usually be emailed within an hour if I break something on Windows, even though I'm developing on Linux. So a dashboard typically looks something like this. You have the build step, and if there are errors or warnings, they'll show up as numbers. Then you have tests, and you can see here one of the tests has failed, and I think 95 passed. And these are all different hosts. Some of them may be Windows, Linux, Unix, supercomputing, and it's pretty easy to set up new hosts. Once we've got the ctest config file, which Alex has added to many of the modules in KDE now, you can pretty much just do ctest-d experimental and send the results in for that particular module. And you can ask users to do that, and if they have a build tree already, it's very, very simple for them to do it in one line. And another thing that I think is very valuable to the KDE project is sub-project support, and that was added in CMake 2.8. So it's a new feature, but it's backward compatible in that we can add the labels, and they will be ignored by CMake 2.6. And so long as the submission hosts have CMake 2.8, then they can separate out the different sub-projects, such as Calcium, Marble, K-Stars, and they will be separated out. So you've got the main project, which is Trilinos in this case, and then various components that are all built as part of this large module. And you have individual warnings, individual test failures, and you also have a summary of the whole project. So it's nice to be able to see a module-wide view, as well as zeroing in on the different parts of the project. You have query filters. So this will help you very easily zero in on the parts of a project you're also interested in. So you can focus on various parts, such as Windows, the compiler that was used, the host, and you can save these as URLs, so you can bookmark them and you can use them in the future. And you can check this daily if you'd like to, or get email notifications on some of these. We have command wrappers as well, which is a nice way of wrapping calls to GCC, so that one source file will only generate one error, and you'll be able to see everything encapsulated as one big block, whereas when we do the parsing, it can often get split into 12 errors, and it's piecing them back together. So this is much easier. It's a new 2.8 feature again, but on the build hosts, they're able to package each call and then see the results of each call to GCC, so we can see exactly which source files are causing problems, and you can easily then kind of go back and fix them, commit your changes, and see the results the next day. There's also coverage, G-curve and bullseye. These are all used within Kitware very widely on all of our projects. So you can see the testing coverage, and these are rough percentages of how much of the code is actually tested. And yeah, you can't read any of this, but it just gives you a good idea of rough coverage. And you can set limits, so you can have a project-specific limit of 70% is good coverage. Anything below means we're dropping off, and we want to address that. Valgrind is a tool I always thought I should run more, but at Kitware, thankfully, it's run on a server every day. We can then go and look at these results. And this is also being done for KDE now, and Alexander Nurndorf set a lot of this stuff up. So you can see various potential memory leaks, and you can then zero in, click on the links, and see the output from Valgrind. And you can then look at that and hopefully go and fix those memory leaks or discard them as false positives. This is typically the kind of email you will get. So it's got a list of the tests that failed that day, the project, the host it was on, the build name, which often indicates the architecture, and then what kind of test it was. So this is continuous, but we have a concept of experimental, continuous, which will constantly check to see for updated source files, experimental, where you're just setting a one-off build of the project. Then you have the overall number, and you can click on these links to see more detail and go to the site. Kitware offers free hosting as well. So my.c-org is free hosting for any open source projects, where you can quickly set up your own projects, and we will host it. We'll store the results in the MySQL database, and it's all just there. It's easy to use. And again, KDE is hosted on here, as well as several other projects such as Avogadro that I work on in my spare time. Sorry? Yep.
About this, how would it work for an app, like KDE app who wants to be tested on here? Would they have to upload and maintain like the entire KDE dependency on all the KDE?
Okay.
So Amwell has to get on it, and we have to like maintain KDE too.
Every build host needs the dependent projects installed.
This isn't a build host.
This is the aggregation of. So this doesn't do the building. You still need to have systems that do builds.
I assume it was.
Oh no, yeah. It's this just collects all of the results in one place and gives you a web interface to view the summary. But you still need various build hosts, so Windows systems, and some of these, like I'm donating my desktop, so at work I leave it turned on at night, and I just add more and more things to a cron job, and it just runs C-test scripts, and I'd happily run Amarok. But yeah, when you build, it needs to have everything as if it was your system. It needs all the dependencies on that system, yeah. But if we can get enough people to donate at least the most important platforms, then, and it's pretty easy to set these up. I'll happily show you tomorrow in the tutorial. We can go through how to set one of these build hosts up. But there's not too much to it, and you just run it in a cron job or scheduled task on Windows. And I've done it for Avogadro on various platforms. I've also helped with VTK and ParaView. And it's a great way of just every single day you have tests. And if someone's got a dedicated system that they can leave running all the time, you can do continuous. So every 20 minutes it will check Git or SVN. It will ask if there are any updated files. If there are, then it will pull them down, then it will rebuild. And it will do a partial rebuild, so it won't clear the whole project. So it's usually reasonably responsive. And then the nightlies, generally, we do a clean build, so we wipe the whole build tree out, make a fresh build tree, and make sure the whole project builds from scratch. But you've also got things like test coverage when you want to test various options. So VTK has about 20 optional parts that you can build or not build. So we use C-test and C- to aggregate the most important options to make sure that they build correctly and that the tests pass correctly for those particular optional parts of the project. And yeah, we have C-testing, we have Purify and Valgrind, the coverage, the configuration coverage, which is really important. So you have different operating systems, if you've got optional libraries that you can use, and then just various optional parts of your project. And a big thing for VTK and ParaView is obviously the image difference testing. So we make a lot of these images, and they're made using OpenGL, and they're rendered on various systems, and we need to make sure that the images are reasonably similar. And this is how we handle it, where we do image diffs. So we have a set of reference images, and we can do image diffs, and we can even specify tolerance for certain images that don't always render exactly the same. And it's just pixel by pixel, and then there's a little bit for offsets that handles some extra logic. But it's useful, and again, C- has support. So if one of these tests fails and you've got an image-based test, in C- you can see the test image, you can see the valid image that you would expect, and you can see the image diff. So any developer can go do that. And sometimes you need to then log into that build host to try and figure out exactly why it's failing in that particular place. But most of the time, this gives you enough information. And some systems we haven't had access to. You change a little bit in the code, you wait for the continuous to come back, you see if it fixed. And it's a reasonable way of having developers who've got limited resources or don't want to have 5 different systems on their desktop. And it will continuously rebuild on at least the major platforms. And then Kitware generally has 3 or 4 major operating systems, and we rebuild continuously throughout the day. Then every night we have 55, maybe 60 different operating system version compilers, etc. They submit every night, so we have really big coverage on a nightly basis, and continuous coverage for the major operating systems. So if you're testing with CMake and C-test, it's pretty easy to add these tests. You just add test, the name of the executable, and then arguments you might want to pass to it. If it returns 0, then it passed. If it returns something else, then it didn't. You can also set other things, so you can use regular expressions to figure out if a test passed or failed, but generally the default and the easiest way of doing it is setting the return value. And ctest is an executable. You will have it on your system if you have CMake. It's distributed with it, and it can run the tests locally, so you can see a summary of what tests passed or failed. And you can also use it as a client for C-. So ctest-d experimental will submit to the C- server if you have a ctest-config.cmake, which if you look in many of the KDE modules is already there. The current state of ctest and C-, like I said, Alexander Nuendorf has already done a lot of work getting KDE dashboards up and running. I'm beginning to work with him more and more on this now, and we're currently testing full KDE modules, and they're being done on a daily basis. And if all developers started receiving email, this is one of my worries. If I was working on Calcium, I don't care if KStars is broken. I don't know their code base, and I don't have the time. And so I'm looking at ways of splitting this up. And yeah, how long, if you're receiving every error for your module, is it going to take before you decide just to filter and push them into dev null, because you don't really want to filter out all the errors in another project in your particular module. For Amarok, this probably doesn't matter as much, but for people that work in the bigger modules, I think we need some level of filtering. So yeah, with KDE, you basically got two options. We can divide the modules into smaller pieces, which is a proposal that's floated around. Doesn't look like it will happen. Or you can use CMake, and the new features in CMake to split big modules up into smaller sub-projects. And all this means is adding a few extra labels in the build files to tell CMake which sub-projects source files belong to, which sub-project targets belong to, and the tests, if we have any. So it's a new feature in 2.8, but you don't need 2.8 for everyone. You just need it on the build hosts, and 2.6 will just ignore these extra labels. So here's an example of how you might add this. This is from Avogadro. So this was what was here before, and you literally add this extra line. So you've got your labels, libavogadro, that's the name of your submodule. And that allows CMake internally to label this. If you're using an older version of CMake that doesn't understand labels, it's just a property it doesn't understand. It leaves it in its internal memory layout somewhere, and it doesn't worry about it. It figures that you're doing something with it. You can create custom subtargets, custom targets for subprojects. So often, if the target is named the same as a subproject, you can just build that target. But if it's a more complex subproject that has multiple targets, you can just create a custom target, which will then be built in the driver script. So yeah, it allows us to build the KDE modules in parts. We do need to figure out the dependencies within the modules to enable us to tell CMake which order to build the various subprojects in. Personally, I think that's a good thing, because we should understand the dependencies within modules anyway. And to explicitly understand this and codify it would be nice. So I'll be working my way through the modules I know better, and then I'll hopefully be working with other people to improve their modules. But it's just adding some labels, and then it's adding an XML file that tells CMake which order to build the parts of that submodule in. And then that will allow developers just to receive emails about issues in their particular subprojects rather than the whole module. Sorry?
So it's possible to associate the tests for a specific subproject, because we have problems today. We can't even build a subproject, but still they're doing all the tests on the top 3. So you don't need all the tests because it's associated for other subprojects.
Yeah, if you can actually add the label property to tests, and then when you call ctest, you tell it to only to only run tests with those labels. And that's built in. It's a very new feature. I mean, it was only in 2.8. So any previous version, and this was actually funded by Trilinos, which was this enormous project, and they could not cope if they didn't have this subproject support. And they have a massive test suite, but again, the developers only wanted to receive information about the tests that failed in their subproject. So yeah, that's fair. And yep.
About dashboard with KDE, a quick Google brings up developer.kde.org /dashboard.
That's different, yeah.
That's entirely something else. Okay.
If you go to my.c-org, then that is the dashboard support I'm talking about, which is the kitware project. I mean, obviously, it's a common name, and it's an obvious name to use for this, so there's a few, but yeah, Dirk around that runs that, I think. And this, yeah, is more the automated building of the modules using the C-test framework.
So is there any plan to make something like my.c-org specific for KDE, or is it already on there?
Right now, it's just hosted on my.c-. If there was interest and we felt there was value, we could run a specific KDE instance. My.c- is intended for any open source project that would like to use it, and we're just getting this up and running. It's pretty new, and many KDE developers aren't even aware that there's a test framework in CMake. So I'm trying to make more people aware of this. It's been very kind of widely used in the scientific community, and it's the core of Kitware is this testing framework. We have massive code bases, and we need to continually test it. And we have various contributors. But I would like KDE to use it more, and I think it could really help us, especially as we're looking at Windows and Mac, and we have a lot of people on Linux. Yep.
We're using it in KDE PIM quite actively. We have KDE PIM, libs, base, and support on that, and for Linux, Windows, OS 10, and we're looking in Maemo and Windows CE as well.
Right.
That's all very nice and works great. We even run Badwin on OS 10, which by the way works fine. But one problem that we have is authentication, because right now the upload is basically totally not authenticated.
Yeah, that's right.
The results, I mean, there is very little to be gained by taking build results, but the world being as it is, at least the denial service is easily possible, and that kind of worries us, because it's infrastructure. As we start to rely on it within KDE, the incentive for people to shoot it up, shoot it down, you know, there are people out there who just service because it's something KDE uses. So I'm worried about that, because right now there's no protection against malicious uploads.
Yeah. I mean, you, as an administrator, I believe you can delete those, but that's, retroactively and...
Right, but I mean, you know, at least some basic mechanism would be needed, I think, is viable longer term for us.
No, I think that's a good point, and it's something that, it would seem reasonable for us to look into. The way that VTK handles this is we have what we call expected nightly builds and nightly builds, and this is in my.c- as well, so you can mark builds as expected, which effectively means that they're builds you trust and they're builds you feel need to be fixed, and then everything else can be anonymous. But some kind of authentication, which could be optionally turned on, seems like it would be a reasonable feature. That would add...
You're not so worried about people submitting kind of results that are wrong, or that are, you know, more worried about the basic denial of service types, where, you know, people would just submit huge amounts of data, or just randomly submit from various platforms. And, you know, there's... I haven't tried to exploit it, but it seems that there are various things that would be pretty easily exploitable right now.
Yeah, I mean, if you tried really hard, you could certainly fill the database up. There are quotas on the, but you could do that, and that would be a problem. I mean, we've been running this for a long time, and we haven't encountered issues like this. But I know KDE is a much bigger project, which has.
We provide a bigger kind of surface area, and it's something that I think just the virtual KDE uploading stuff there will make it a potential target for this.
Yeah, I certainly, I agree. It's something we should think about. But I think the framework as a whole does provide a nice way of centralizing these results. And
great. As I said, it's great. And for us in PIM, it's beautiful. It works. You can click your way through to KDE PIM, you'll see all the test results and everything for the various platforms.
Yeah, I'd encourage you to have a play with it and look at the results that are up there. It's a good point. So sorry?
Sorry, while we're still on C-, is there any plan for Git support anytime soon?
I'm going to talk about that, but it's there already. C- needs more exposure in the interface.
Yeah, the interface only shows CS and SVN.
But it actually internally supports it already. It's just it doesn't get exposed very well in the interface, which is being worked on right now. But the important bit is that C-test supports it, and that's there in 2.8. But the web interface needs to be upgraded a little. Yeah. So C-test driver scripts, these allow you to do things that are a little more complex if you need to customize for your project. If you just want to do something fairly simple, you can just do ctest-d, experimental, nightly, etc., and it will run the whole thing, build it, submit the results. It allows you to loop over each subproject, and so it's required if you want to use the subproject support. And you can build the custom project target, you can run the tests. Tomorrow, if people would like to look at this, I have some examples where we can go through a CTest driver script, and this allows you to drive the subprojects. And you can submit the result of each part, so you can actually configure the project, submit the results, build the project, submit the build results, and then you can run all the tests and submit those. And so the developer can see the results in pieces much quicker, rather than waiting for the whole process to finish, which for projects like VTK can mean the developers see any configure errors maybe half an hour before if they had to wait for the whole thing to complete. So this is quite nice. Again, new features in CMake 2.8. So yeah, the CTest driver scripts, you use ctest-s and you can run this script. It has access to basically the whole of the CMake language. And you can submit parts. And as you can see here, you can have various systems. VTK, for example, has supercomputers, desktops, laptops, I don't think there are any embedded systems, but yeah, it's basically anything you can build, you can then submit results from. And when customers have issues, we can ask them to submit an experimental build, and then we can debug the output from the failures without having to ask them over the phone or asking them to email us the relevant parts. So this is quite useful just to be able to interact with customers more easily. And again, with users, when you're doing support and someone says, I can't build KDE-libs, you can ask them to run a ctest-g experimental and then have a look at the results. You just need to know their host name so you can identify the result as it goes up to C-, which is a good thing in some ways, but as Till points out, could obviously be a bad thing if we had 1 million people do that. CTest and Git, as you were asking. CTest has to understand the version control system because it needs to know what files have changed. It also needs to know who changed those files so that it can actually email the people that are responsible for breaking the build and tell them that there's a problem with a commit that they made. And it also needs to know for a nightly dashboard what to check out, and for a continuous dashboard it needs to be able to query the version control, see if anything's changed, and then build if anything has changed. CMake 2.8 added support for Git, Mercurial, and Bazaar, and we also abstracted the support for version control. So it's much easier now to add new version control systems in the future, although it looks like our support is pretty good because we already had CVS and SVN, and now the major distributed version control systems are added. This is one that Bill and I have been talking about a lot recently, but in the new world where you have Git and you can push experimental branches, can we test a change before it's actually committed? And with SVN, that's just not possible, or it's not practical. But with Git, you can have your own personal branches, which you can push, and then you can ask C- to test this branch. And then if it passes on the supported platforms that you asked for tests, then you can integrate the code. And this means that you can keep your master or your head much cleaner, much more stable. And we have some experiments going off internally where we're examining how to add this support to C-, how we can interact better with Gitorious. So internally, we're also looking at moving to Git. We may well beat KDE. We're hoping to be moved within 2 months. When I arrived at the company, I realized we still use CVS, and then I heard that we may be moving. I obviously encouraged that a lot, and I've been involved in that migration. And so this is very important to us internally, as well as with some of the external projects that we're moving over to Git that we're moving over to Git as well. So we want to be able to test large changes. And as a policy item, you could decide that you only want to allow people to commit after they've tested these changes. We think it will be a little freer with the projects we work on, where we would just, if you make a big change, you can request a pre-test, if you want to put it that way, where you can just ask, does this build on all the major platforms? Does it pass all the regression tests? And so this is just a little graphic to demonstrate what I mean, where you have all these commits out here. Developer decides that they think these 3 commits are ready, so they push this branch. And then maybe on Gitorious, if we could add some interface to that, you can then ask for this branch to be tested, much like a merge request. And then maybe on free platforms, it would be tested. The developer would be informed of the result. If it passed, it could be pushed into a so-called blessed master, which would be where everyone else is pulling from. And this would result in much better stability in general if you were able to do this rather than just testing on your own system and pushing into the blessed master. And Kitware is also hiring. I really like the place, but we're looking for people that work in the C++ and Qt areas, as well as OpenGL. And we work across a bunch of different platforms. I'd be happy to take any further questions. I'll be running a tutorial tomorrow, so if you'd like to learn a little more and go over some of the scripting, I'd be happy to do that. And yeah, CMake is much more than just a build system, and we should try and leverage more of that. Thanks.